Yeah, well, tonight at Bacononia Forge, I thought I'd do something a little bit different. Most of what you've seen so far has been pretty random goings on, and probably a little bit mysterious, I guess. But yeah, as you can see, the shell is complete. It's a little bit rough. I mean, it's a forge. It's not an ornament. So, you know, I'm pretty happy with how it came up. It's just in primer at the moment, so I sure have a little temporary Bacononia Forge logo. So, yeah, so the principles involved here. This body is merely to contain the burner and the refractory material. And the refractory material is one which, I guess, primarily reflects heat as opposed to insulating. Even though it does that, that's a secondary function. Obviously, the more heat you can contain within that area, the more efficient your burner will be, and consequently, you should be able to use less fuel for any given temperature within the space. That's why I decided to go with a ribbon burner assembly, which using forced air as opposed to atmospheric pressure and the Venturi effect of the standard type blowtorch. I guess you have a little bit more freedom of control, more even spacing of the heat. Aside from that, it's a more interesting project to be involved in. And being a cheapskate, I was hoping to skimp on gas a little bit, but I think I may have gone a tad overboard on the burner size. That just means I'll have to push the airflow back. I think I'm running too much air, but I'm not going to bother to try and fine tune it till it's actually in the forge. Yeah, so the next stage is to put some refractory material into this assembly, and as you can see here, I have 2 meters of what Pottery Supplies in Brisbane, which where I live is one of the few places which I can realistically source these sorts of things without waiting for ridiculous amounts of time or paying vast shipping. They were out of stock. I had to wait a number of weeks. That's why this project's drawn out so long as well. But in here is a K-wall blanket, which is, from what I understand, a ceramic fibrous composite. I mean, it looks like a blanket. It looks like similar to a fiberglass bat, which I imagine somehow the kaolin, which is clay, white clay, fine white china clay, is either extruded wet into a fibrous form and then fired at, I would imagine, extremely high temperatures to, what's the word, vitrify? Either way, however it's made, the effect is you have a very, very high refractory, lightweight, flexible, easily workable. I mean, I'm going to cut this with probably this knife once I clean it up a little bit and sharpen it properly. So, theory is I'll take 3 layers of this, which is 25mm thick or 1 inch, find my length, insert 3 layers in roll form. I'm hoping it's going to fit through that entrance. If it doesn't, I don't know what I'll do, but I'll work something out. And then to that will be applied a K-wool hardener, which is a colloidal silica solution, I believe, which is applied to the wall once it's in situ, and it will rigidize it, make it harder. Because clearly you don't want these fibres flying around. I mean, this material here, this is why I've got my gloves and mask and whatnot here, is at least as hazardous as asbestos, if not more so. You want to have complete body coverage. I mean, not necessarily hazardous material gear, but at least long sleeves, long pants, gloves, safety glasses, preferably a respirator. Definitely some breathing protection anyway, and possibly even eye protection. But it's as still as anything here tonight. I mean, it's a winter's night. It's not even cold here. I don't really even need this jacket on, but so there won't be much air moving around. I'm not going to be doing a lot of cutting. So once this layer is installed, as I said, I'll install the hardener. Then I'll cut myself a slot for the burner, which I'll just use a knife, I guess. Once the material's in place, I'll cut them as I install them and align the burner to where I think it should sit now that I've seen how it's firing a jet. Yeah, I'll probably only rigidise the very inside layer and around where the burner's going to install and where the doors are. Because then over the top of that I have some pyrocrete, which is a refractory cement. I guess it's a high alumina cement. It's alumina, silica, it's a bit of like similar to dolomite, a couple of magnesium, a magnesium compound. Anyway, there's a couple of others, but primarily alumina. It's about 40 to 50% alumina, which is a very high refractory material. This is supposedly workable up to 1700 degrees. Ah, yes. The kaolin wool, this fire, what do they call it? Fire face? Hot face? Is rated to 1400 degrees Celsius. I also have half a metre. I've got 2 metres back because I thought I might even build more than one forge, which I probably will. I also have this, I have half a metre of what they call backup blanket, which you can back behind your hot face. It's only rated to 1260. It's less dense. I just bought that because it was a little bit cheaper, and I thought I might fabricate a few stops or use it in some doors or other various fittings and assemblies that might go along with this. Yeah, anyway, this pyrocrete will then be pasted onto the final inner layer of kaolin. So yeah, I mean, I don't know how much concreting people have done. I've done a fair bit. I mean, it's similar in consistency. It's like a very coarse mortar. If you've done concrete and worked with concrete, you'll see it's a typical, pretty typical sort of aggregate sand and cement blend. So yeah, obviously you can fiddle with those ratios to have different qualities in the material, you know, depending on whether I want to. I'm probably going to cast myself another shelf to put in the bottom, as opposed to form it in place, as a lot of people seem to do. But I'll see how that goes. I also have some silica sand there, which is just plain white sand. Probably came from bloody Stradbroke Island or something. I have some grog, which is just fire clay, which I can now make my own varying ratios of aggregate sand cement mix for the varying purposes. You know, I want it a bit harder. I'm not so worried about its longevity. I'll obviously use more silica and grog and make a harder refractory structure for basically disposable fire bricks. And kiln shells are just too expensive to buy. You know, these things, they wear, they're subject to temperatures. You know, I imagine this will probably run somewhere up to, well, probably beyond 1400 degrees anyway. Yeah. So the process of applying the refractory, at that point, I'll probably put a reasonably thick layer of pyrocrete maybe bulk it with a little bit of silica, a little bit of the grog, and build up and leave myself enough room. I would imagine I've cast a couple of little pyrocrete bricks here. I've fiddled with ratios and I've worked out a few different. I've got a few more somewhere else, but some of these have even been fired. I just put them on the stove and built a little cave out of them, and heated them up till they were glowing. So I'm sort of aware of, what the different ratios, how they feel, how they look. Not that that's really important, but more so their density, their hardness, their resistance to wear. For instance, if welding and flux, borax, it's quite aggressive towards silica compounds. Perhaps, if you're going to be destroying the kiln shelf or whatever other refractory you have in there anyway, you could perhaps use a high silica, then the capacity for that to shed, as this one is here, shed a little bit of sand at all times would make the process of cleaning out and keeping the flux, less likely to bind into the, not so much bind, but find a reasonable area of contact with the material. Anyway, it's all just theories, it's all just experimentation up to this point. Anyway, to line it, thin layers, very thin layers, build up thin layers. There again, if you've done concreting, tiling, rendering, any of those sorts of things, most of those principles will apply. I mean, it's the same process, I think one of the critical factors that some people miss, and I'm not an expert on this, but having experience in other areas of it, having a wet substrate to bind to when you're using particularly cement-based materials is usually very important when you want a good adhesion. So I was just distracted by some sort of arachnid. So build up thin layers. I'm thinking it probably won't end up more than about 10 mil, 12 mil. Even that is possibly a bit too thick. Because then on top of that, anyway, I'll have a feel. I'll have a feel for it as I put it in. It'll become self-evident. Plus the need to level it as the light aircraft flies by is also going to dictate the thickness of the coating. And then after that, I reached a bit of a hurdle because many of these kilns are lined with a very, very thin layer of a very highly refractory material. Some people call it nuclear reactor lining paste, or I don't know what's used for that, but primarily high zirconium and possibly other compounds. Even titanium dioxide, I think. Anyway, zirconium is one of the primary ones, which is an even higher refractory material, if that makes sense. A more refractory material, which is capable of sustaining higher temperatures, but is very expensive. And it's commonly used as an abrasive. That's, if I recall correctly, I think it's one of the harder substances, near diamond anyway. It might be artificial diamond. I think cubic boron nitride's harder. I wouldn't quote me on that though. Anyway, very hard. Very hard. I'm not going to use any of those because they're too hard to find in this country, and the shipping and waiting times and vulnerability of pre-mixed materials such as these in international shipping is not really favourable. So I went with the nearest I could find, which is a product Pottery Supply sells, which is called blackite or blackite. Most people I've heard refer to it as blackite. I think it's manufactured by a company called Morgan Chemicals or Morgan Refractories. I don't really know anything about it. I just researched this product, and if there again, if I'm going from memory, I'm pretty sure it's stable to approximately 1760 degrees. There again, don't quote me, Celsius that is. But its primary purpose is as a mortar for binding together other refractory materials, primarily fire bricks. But I did use it to coat my ribbon burner. I put a fine layer of that over the ribbon burner was cast from pyrocrete, obviously, and I put probably a 1 millimeter layer of this over the top, just primarily for its refractory properties. And from having used that, I'm fairly confident that should be adequate. There wouldn't be a problem with thinning it. It's very slightly. As I said, I have worked with it. It's easy to work with. It's a very fine consistency. But yeah, that's going to be my solution. But that layer is, it's subject to the most wear of the whole forge. So even if doesn't have the longevity of some other coatings, I'll be monitoring this and working on it. So it's not going to be a huge job just to replace or patch those layers. We'll see how it goes anyway. I have heard of other people using that same product. Unfortunately, I haven't heard any real follow-up on how effective it was. But given the nature of it, I'd be pretty confident it won't be a total failure anyway. Okay, well, I'm going to leave it at that. I've probably rambled too long and I meandered and wandered around the point. But I think that covers the basic principles involved. So I'm going to get to it and embark upon this project.